Okay, we are on 7.09 today. It is the inverse of a matrix. And it's going to be good review for what we did together in class on Monday of actually solving using a matrix. So it says let A be an n by n matrix. Hold on, take this off. Okay, so let A be an n by n matrix and A to the negative first, which is A inverse, be an n by n matrix. So A to the negative first is the inverse of A if you multiply A times its inverse, or using the commutative property, the inverse times the original. If when you multiply those together, they give you what's called the identity matrix. So what an identity matrix is it's pretty much just like how we set it up with the staircase of 1 and all the zeros, but you have nothing that it's set equal to on the other side. So you'd have like your staircase of 1 and zeros above and below. So that would be your identity matrix. Not all square matrices have inverses. And if it's a non-square matrix, then it cannot have an inverse. So you have to be a square matrix in order to have an inverse, but not all square matrices do have inverses. Definition: a matrix which has an inverse is said to be invertible or non-singular. It's just some vocab words here. For number 1, it says show B is the inverse of A, where A and B are given those matrices. So we need to show that either A times B equals our identity matrix, or B times A equals our identity matrix. So I'm just going to go in the same order it was given because that's just easier. So I'm going to do A times B. So if you remember, when we multiply two matrices together, first of all, those middle numbers have to be the same once we find the order. So a 2 by 2 and 2 by 2, middle is the same. So our new matrix will be a 2 by 2. And then we want it to always go rows by column. So the first one we are always taking the rows from, and the second one we're always taking the columns. So we're going to do -1 times 1 plus 2 times 1. And we go right in order, -1 times 1 plus 2 times 1. Let's go to row 1, column 2, which will be -1 times -2 plus 2 times -1. Now I'm going to go to row 2 and column 1. So -1 times 1 plus 1 times 1. And row 2, column 2, -1 times -2 plus 1 times -1. Let's see what we get. For the first one, -1 times 1 is -1, plus 2 is 1. -1 times -2 is +2, minus 2 is 0. -1 plus 1 is 0. And then 2 minus 1 is 1. So we did, in fact, get the identity matrix. Therefore, B is the inverse of A. Okay, so that's just kind of showing that it's true. So I gave you the original, I gave you the inverse. Now I want to talk about how to find the inverse given just the original. So option 1 is the shortest option, but it does require memorization. So if you're someone who can memorize things easily, then this might be a good way for you to try it. So I'm going to give you the formula for that up here. So let's say our matrix is A, B, C, D, and we want to find the inverse of that. We're going to do 1 over, you're going to multiply A times D, so the diagonal, the first diagonal, minus the other diagonal. and multiply that by the matrix. So you're going to switch A and D, and you're going to negate along the other diagonal. So you switch the first diagonal, negate the second diagonal. Okay, so this you'd have to memorize. Again, you do not have to memorize this. I'm going to show you another way to do it that does not require any of this memorization. So for this particular problem, let's try out and see how this would work. So I've got 1 over, so A times D is going to be this diagonal. So 1 times -3 is -3. 4 times -1 is -4. So it's minus -4, which is plus 4. And then we switch along the first diagonal and negate along the other. And so this is 1 over -3 plus 4, which is just 1. So I have 1 times that matrix. So my final answer would be this. So if it wasn't 1, it would be a little bit more work, but not much more than that. Just multiplying through each number by another number. So that is option 1. Option 1. Option 2 is don't memorize that, and you're going to solve it. And something else I didn't mention here. This only works for 2 by 2. Only works for 2 by 2s. Oops. Only works for 2 by 2s. So all the others you're going to have to do option 2. So for option 2, you're going to start off with your original matrix, and you're going to draw a line. After that line, you're going to set up your identity matrix. And this is kind of cool how this works. Okay, so whatever size the original one is, you keep the same size. So what we're going to do is we're going to try and like flip-flop. So we want this side over here to become the identity matrix. Once we do that, whatever's left on this side, that new matrix, that will be the identity of it. So we do the same process we did on Monday, where we first get our leading 1. Oh, good news again, which happened a lot in class on Monday. It already is a leading 1. So we're done with that. Now we work column by column. So in column 1, we want to get this guy, -1, to become 0. How do we do that? Well, we multiply the lead 1 by 1 and add it to -1, because you want to think to yourself, what -1 plus or minus what would give me 0? Well, -1 plus 1 gives me 0. So I need to get this 1 to become a 1. Well, good news, it already is. So the first row, keep exactly as is. The second row, we're going to take 1 times row 1 and add it to row 2. So really all you're doing is adding row 1 and row 2. So I have 1 minus 1 is 0. 4 minus 3, 1. 1 plus 0, 1. And 0 plus 1 is 1. Almost done. Now, again, I get my lead 1. So column 1 is done. Now we move on to column 2. So we need to get our lead 1 and then zeros above and below. Good news, it's already a 1. So now I need to just get this 4 to become a 0. So to do that, I think 4 plus what would give me 0? Well, 4 plus -4. How do I get this 1 to become a -4? Multiply by -4. So -4 times row 2, you always multiply the row with the lead 1 by something. So we take, that's in row 2, so we're multiplying that by -4, adding it to row 1. Row 2 is going to stay as is. So I've got -4 times 0 is 0 plus 1 is 1. -4 times 1 is -4 plus 4 is 0. -4 times 1, -4 plus 1 is -3. And -4 times 1 is -4 plus 0 is -4. So you should notice our answer we got over here, same as over here. So the inverse of A would be -3, -4, 1, 1. Now, before we go on, I want to talk about how to check it in your calculator. So I got this, so hopefully will help you to do it in your own calculator. And to do that, I'm going to go to second matrix. I'm going to go over to edit, and then I'm going to hit enter. And this matrix I'm going to put in, I'm just putting in the original one that it gave me, is a 2 by 2. So that should set up the size I see, which it does. Good news. So 1. And after I enter each entry, I just push enter. And it does row 1 first, and then it jumps down to row 2. And it moves you to the next one each time. So that's my original that I was given. Now I'm going to hit second mode, so quit to my home screen. Now I'm going to go back to my matrix, and I'm going to take A, and I'm going to hit the x to the negative first button for my inverse. And then I'm going to hit enter. And it literally just gives you the answer. So should be pretty straightforward to find your inverse. Just remember that button on your calculator, x to the negative first. Okay, let's do another one. So this one is a little bit bigger. We have a 3 by 3, which means that you can't use that quick trick, that little formula you have to memorize. You have to do it the second way. So let's go through it together. So you've got 1, and if you are feeling confident right now and you think, oh, I got what we just did, you were feeling good after doing those homework problems after Monday's class, then go ahead and pause the video and see if you can do it yourself. And then just come back and check your answer. But for those of you who are really struggling still, let's do it together. So what I want to do again, my main goal here is to take this left-hand side right here, and I want to make that become my identity matrix. And whatever I do to each row, I have to do to the whole row straight across through the line. And then whatever I end up with over here on the right side of the line, that will be the actual inverse of A. First thing I do is I want to get a lead 1 in column 1. It's there again. So now I need to get zeros below. So to save some time, I'm going to do them in the same step. But if you are more comfortable doing one at a time, that is 100% okay. So first I'm going to just rewrite my first row. Now in the second row, I want that 1 to become a 0. So 1 minus 1 gives me 0, which means I need this one to become a negative 1, because I always multiply the row with the lead 1 by something. So that will be negative 1 row 1 plus row 2. So we go ahead and do that. And I get 0, 1, negative 1, negative 1, 1, 0. For the 6, I want the 6 to become a 0. So I'm going to multiply this lead 1 by negative 6. So negative 6 row 1 plus row 3. You always label it on the new matrix where you've done the change, and always on the row that you've already changed. So I've got, and always multiply the row with the lead 1 by that number. So negative 6 times 1 plus 6 is 0. And then I'm just going to kind of go through these quickly to save time. Again, if you at any point you're feeling confident that you can do it on your own, pause it, try to do it on your own, and then check the answer. Okay, so we are done with column 1. Now we want to move on to column 2. So column 2, we need that staircase 1. So here's where we need the next one. Good news, it's already there. So now I just need to get zeros above and below that in that column. So to get negative 1 up here to become a 0, I need to add it to 1. Well, good news, this is already a 1. So I'm just going to take row 1 times row 2 and add it to row 1. So the row that's staying the same here would be the row with the leading 1. So I'm going to get, my 1 will stay here. Now that becomes a 0, negative 1, 0, 1, 0. And then we need to get this 4 to become a 0. So I need to add it to negative 4. So what would I multiply 1 by to get it to become a negative 4? I would multiply by negative 4. So negative 4 times row 2 plus row 3. And then that stays a 0, 0, 1, negative 2, negative 4, 1. Okay, Now, again, we have some good news that our next leading one, that staircase, is already a 1, so we don't need to multiply by anything to get it to become a 1. Now I just need to get these two to become zeros. So to get the top -1 to become a 0, I need to add it to 1. So I'm going to do row 3, 1 times row 3, plus row 1. So this will give me 1, the zeros will stay. Now that'll become a 0. This will become a -2, -3, and 1. Middle row, row 2, is going to stay the same. And then row 3, oh, no, actually, sorry about that. That will not stay the same. We want that one to become a 0. So we want this to become a 0. So how do we get it to become a 0? We multiply 1 times row 3 plus row 2. So here now I have 0, 1, 0, -3, -3, 1. And then fill in my last row. That's the one that will stay the same. And if you notice on the left side, we have our identity matrix, which means the inverse of A is equal to the right side, -2, -3, 1, -3, -3, 1, -4, 1 would be our final answer. And then I'd like you to go back to your calculator and type in the original. I'll just write out the calculator steps. So check in your calculator. So go to second matrix, type it in, and then use that x to the -1st button to find the inverse of it. So edit it in here, and then just type it in. Okay. Number 4 says, does A have an inverse? Explain why or why not. Okay, so I want you to think about this and say, okay, well, can we tell off the bat? No, it is a square matrix. It's a 3 by 3. So let's start solving it and see what happens. So I'm going to copy down the original here. And then on this side, I'm going to do my identity matrix. All right, so we are going to work to get this left-hand side to be, oops, I took off the whole line, trying to shorten it. I want the left side to be the identity matrix. Good news again, I gave you guys a 1 right there. So now I need to work on getting zeros below for column 1. So I'm going to rewrite the first row. And then the second one, I'm going to take -3 times row 1 and add it to row 2. So if I do that, it should give you, and again, try pausing the video before you do these steps, and then check my work. So for the next one, try to get this -2 to become a 0. So pause the video right now. Okay, so what you should have done was 2 times row 1 plus row 3. And you should have gotten 0, 7, -2, 2, 0, 1. So you can continue, but I want to point out at this point, if you notice that if you were to add these 2 rows together, then you would get 0, 0, 0 on the left, but not on the right side. So you may notice at this point, if you add row 2 and row 3, you will get the 3 zeros on the left. Okay, but maybe you don't notice that. So maybe we continue. So if we continue, and that would be not on the right. Okay, so let's continue to see what happens if you didn't notice that. So now we're done with column 1. Column 1, check. Let's move on to column 2. So now we need to get this to become a 1. Okay, so whenever you're trying to get a lead 1, that's when you want to multiply. So you're going to multiply by its reciprocal. So first, I'm going to keep top row the same. This is the step that you're only allowed to do this one step at a time. You cannot do any other steps when you're doing this. So we're going to multiply row 2 by negative 1/7. So by doing that, negative 7 times negative 1/7 will give me a 1. Then I'll have negative 2/7. Then I'll have positive 3/7. Then I'll have negative 1/7 and 0. So again, that's the only thing you're allowed to do in that step is get this lead 1. We got it. Every time you're getting a lead 1, you're always multiplying by the reciprocal to get the lead 1 if you don't have it already. Then we're going to do our multiplication and addition, so add the rows together to get this 2 and this 7 to become zeros. So we're just doing the same process that we've been doing. So to get the 2 to become a 0, I'm going to do negative 2 times row 2 plus row 1. So this time my lead 1 is the middle row. So that's the row that is staying the same. And I'm going to pause the video, try to do it on your own. Because we have some fractions here, if you need to use your calculator, you can. But it'd be great if you can try to do it without. You will have some of these that you'll need to do without a calculator. But pause it and then compare your answer to mine. So up here we're going to have a 1. Then we're going to do negative 2 times 1 plus 2 is 0. Then we're going to do negative 2 times negative 2/7, which will give and then plus 0, so that'll just give us positive 4/7. Then we have negative 2 times 3/7, so that'll give us negative 6/7. And we want to add that to 1, give us 1/7. Then we want to do negative 1/7 times negative 2, which will give us 2/7 plus 0 is 2/7. And then 0 times negative 2 would give us 0 plus 0 is 0. All right, and then for the bottom row, we're going to do negative 7 times row 2 plus row 3. So with that one, I'm going to get 0 still. Negative 7 plus 7 is 0. Negative 7 times negative 2/7 is positive 2. Minus 2 is 0. Then we're going to have negative 7 times 3/7 would give us negative 3 plus 2 is negative 1. This one will give us positive 1, because your 7s would cancel, get positive 1 plus 0 is 1. And then 0 times negative 7 is 0 plus 1. So here, right here is where we're really focusing on and saying, okay, at this point, it's impossible to get that identity matrix, to get the identity matrix on the left side because you have all those zeros. And we know all those zeros is not equal to this. So it's not even like an entire row of zeros. So as soon as we get all those zeros on the left side, we know that it is not possible. So there is no, therefore, no inverse. So you could say that this is singular is another way people say it, or just saying it's impossible is fine too. All right, that is it. Let me know if you do have any questions. Enjoy your day.